In this modern day and age in which most of us happen to live, it's absolutely amazing how little money you need to spend in order to get a decent multimeter. Just $50 can buy you one that's very well equipped and reasonably safe. $20 will get you one that still has a lot of decent features, even if it is a bit safety challenged in some situations. But what if you don't have $50? What if you don't have $20? What if all you have is about $13 in sales tax? Well, then I guess you could buy this. This is Wal-Mart's very own hyper-tough branded Category 3 digital multimeter, or so they very much claim. I will note right away that on the face of the multimeter is the ETL Intertech logo, which I could actually put on the camera if I was watching the viewfinder. What a professional I am. Of course, the camcorder goes out of its way to make me look even more professional by not focusing the way it's supposed to, which means that it's probably contemplating doing something expensive, even though I definitely don't want to buy another camcorder at this particular juncture, nor do I really have that in my budget. Anyway, getting back to the subject at hand here, one could accuse Wal-Mart of a great many things, but I don't think that falsifying a multimeter safety rating is amongst them. However, it should be said that even if this thing passed the ETL tests that are necessary to earn that mark, it doesn't mean that the multimeter kept on working even under very adverse conditions. It just means that it failed safely. So this multimeter might well die if it is subjected to conditions above and beyond what it's really made to handle in day-to-day operations, but hopefully it would at least do so somewhat safely. So let's go ahead and take a look and see what we have here, what you get for your $13 in sales tax. The packaging is very easy to open. You just fold this little plastic lip back at the edge. You can pull the card out of the back of the box, and then the multimeter is yours to do with as you please. And of course you get the multimeter itself, right there. You also get what look to be a pretty decent, if cheap, set of test leads. These actually do have little shrouds over the end of the probe tips. And the probe tips are not as sharp as some I've seen, but I really think that's okay because I don't like inadvertently lancing myself open with these things. Now these little tips, these little shrouds, have to remain on here to help the meter meet its claimed Category 3 safety rating. So even if you don't want to use these, and sometimes there's a very good reason not to, you should take a great deal of care not to lose them along the way. Something you probably can lose, though, are these little caps that come in the other end of the probes that are designed to go into the meter. Now these look pretty shallow to me, so I don't know if you have something like a better quality set of test probes or something like a set of banana plug adapters or similar, that you could actually use them with satisfactory results on this multimeter, because these do look awfully shallow to me. So a regular probe may well fit, but it's possible, depending upon how well made they are, that some of the conductive surface of the probe could be left sticking out of the meter and creating a potentially dangerous condition. We also get a little battery. Now you've seen this brand of battery before in one of my previous videos, and there it was definitely off to a bit of an inauspicious start because the battery was completely dead and worthless. That's from the Harbor Freight Automotive Analyzer meter review video, where one of these batteries was included in the package. At least I think it was this same brand. I'm not 95% sure that it was, so I'm probably wrong. But that battery was completely dead. Hopefully this one will fare a bit better. It's wrapped in plastic, so we'll have to open it up. Which wasn't actually too hard to do. It has a pretty short expiration date. Stamped on the bottom is January 2020. So if you do get one of these meters and you plan to store it for a while, you might want to go ahead and remove the included battery from the packaging just in case it starts leaking and decides to wreck something. You also get a nice little instructional pamphlet that's pretty well written, but was apparently developed with other meters having more capabilities than this one offers in mind. In particular, there are sections about measuring temperature and other test ranges that this meter does not have. So let's go ahead and pop the back off of it, although before I do that I did promise I was going to test that battery. Although, as you might remember, I think I got bit doing that as well, because as it happened, the battery looked good in an open circuit test. I'll go ahead and turn the backlight on this meter. And we'll take our test leads here and we'll just see what this battery's state of health is. Well, at almost 10 volts open circuit, or very close to, I'd say that's a pretty good battery. We'll see what it actually does under load when we get it into the meter here. And of course, when I take the back off of this, we'll also get to see what the construction quality looks like, and if this thing actually has a prayer of meeting the Category 3 claimed safety rating. I guess, to be perfectly honest with you, I'd have to say that I have my doubts. I can't imagine this thing being much more than a slightly re-embodied, reimagined form of the ubiquitous, cheap, and more than a little dangerous DT830 multimeter. It's certainly light to the touch, light in the hand, but it doesn't feel cheap. The plastic is, however, very smooth and very slick. Now, I was talking about the instructions mere moments ago, and I would show them to you, but since I just so happen to be a guy, I've already expertly lost them. So go ahead and pop this open. And indeed, that is what it would appear to be, little more than a DT830 multimeter in a slightly different casing. And notice there are two openings up here above the circuit board. I can't possibly imagine what those might be for. Perhaps a model with a larger display, maybe some kind of backlight or something along those lines. You certainly don't get a backlight with this. The circuit board has printed on it D14620. I don't know if that represents the actual meter platform upon which this is based. You can see that there are no adjustment trimmers of any kind on this board. It looks like all the adjustments are done electronically by way of this unpopulated communications header over here. That undoubtedly, as these roll down the line, they are tested and calibrated, hopefully correctly, and then put into their packages and sent off to you and me. The chip is a blob on board or chip on board style construction, which is very common to see in this sort of thing. It's very cost effective to build them that way. Here the actual maker of the meter is revealed. This is an All-Sun branded test instrument. Wal-Mart actually packages some other All-Sun meters in things that are sold under their own name, but where the packaging actually says something like Hyper Tough Circuit Test Kit or similar things, they don't make any effort whatsoever to hide the meter's origins. It says All-Sun right on the front of it. You can see that there are two ceramic-bodied fuses here. Ostensibly, they're supposed to be high breaking capacity, high rupture capacity types. I think they're probably a bit small to qualify, but one thing we might do, we might just pop one or two of them out of the board here. And amazingly enough, I did not manage to send it flying all the way across the kitchen. I'll just take a look at this and see if I can find any kind of a voltage rating on it, or a manufacturer name. I see no manufacturer name, but it is a 300 volt 10 amp fuse, so that one is obviously for the high amps current measurement scale, which only functions on direct current, by the way. You cannot make alternating current measurements with this meter, but it's probably just as well, because I don't think the test leads are up to the challenge of making a 10 amp measurement for more than a scant few seconds, and very likely this current shunt, that copper colored bar that you're looking at right now, isn't capable of doing the same thing either. So we'll go ahead and pop that out of there, and that one did go on the floor. So I'll get it back, and thanks to the magic of video editing, we'll be back in just a moment. Alright, we're back, and I've gone ahead and adjusted the tripod downward a little bit, as well as zoomed in the camcorder's lens, so that hopefully you can see the meter a little bit better, and hopefully everything will remain in frame from this point going forward. You see, I'm actually using a camcorder tripod right now, and if those of you who have stereo speakers or headphones can probably tell already, I'm actually sitting to the right of the camcorder, which means I can't actually see what's going on with its built-in monitoring display. So I have to set it up as best I can and hope that I'll keep in mind where the boundaries are as I go through this meter. I went ahead and recovered the fuse that landed on the kitchen floor. This is rated for 300 volts, 250 milliamperes worth of current. So it is very likely the fuse that is used to protect the ohms or resistance measurement scale. As far as protections in this meter go, beyond the fuses, I don't really see very much. There is a PTC resistor down here underneath the current shunt. This works by heating up, and as it heats up, the resistance increases considerably. thus halting or greatly reducing the electrical flow, hopefully in time to prevent any circuit board traces from evaporating or the meter from exploding in your hand, which again, I wouldn't be too sure might not happen with this. I've kind of got my doubts that this is the kind of thing you would want to use on line voltage, and if you did, you'd want to be supremely cautious at all times that you had it set to the right range. And I would definitely keep it out of your electrical service panel and probably away from anything that uses a 220 or 240 volt circuit. Here in the United States, as well as many other countries, we actually have 120 volt branch circuits to most things in our homes and businesses. And then we have 208 or 220 that is employed, volts that is employed for higher current loads like stoves, air conditioners, stuff along those lines. Those of you who are in a 220 volt country natively will obviously think that we're completely wrong for doing so, but that's an argument to have on another day. Thank you very much. Let's move right along to this little battery. Go ahead and plug this into the meter. Now this is as cheap a carbon zinc battery as has ever been made, but I still think that it will deliver exceptional runtime. Some time ago I took a DT830 multimeter and slapped a name brand alkaline battery in it, turned it on, and expertly left it sitting on my workbench. It lasted about 6 weeks non-stop before the low battery indicator finally came on, which on those is set at a threshold of approximately 6 volts on most that I've seen. Now that was a name brand alkaline battery. This one won't manage to do quite as well, but I would still expect that if you left it on continuously, it would manage to last for about a month before the meter finally complained of low voltage and told you to replace it. And when your meter does complain of a low battery, you really should replace it, because in some cases it will lie to you. We might check and see what this thing does a little bit later in the video by virtue of a variable regulated DC power supply that will let me simulate a low battery condition. So let's go ahead and put the back cover on it. If you are the kind of person who thinks they might forget and leave their multimeter on unattended at the bottom of their toolbox for a month or so before they notice it, you might want to aim a little higher up market than this and get a multimeter that actually does have an automatic power off capability. The screws on the back cover of this meter are only going into plastic, so it behooves you to make sure that they've seated in their threads, and it's very easy to do this even if you've never done it before. Just turn your screwdriver backwards and listen for a click. When you hear that click, you can be fairly certain that the screw has actually properly seated in the existing threads. If you don't do that, the screw might actually cut new threads, and eventually it might wear out, wallow out the plastic to the point where it will no longer screw in properly, or it might actually cause the plastic posts inside the meter to split apart. And then you'll really have a problem. And no, you absolutely should not use a meter whose back cover cannot be securely affixed, because if something did go terribly wrong, this casing is designed to contain the explosion. Let's go ahead and take a look at some of the things that you get as far as test ranges and input connections are concerned. The high current test jack is separate from all the others. This is where you would connect the positive lead if you were going to make a 10 amp high current measurement. And I should expand on what I said earlier. This meter is perfectly capable of measuring alternating current voltage. It just can't measure the actual current in an alternating current circuit. This is for DC only, and again, I'd say you probably might as well forget that it exists. For the low current measurement, as well as ohms resistance and the diode test and voltage measurements, you use this middle test jack to connect the positive test lead, and then at all times the negative or black colored test lead is connected to the common input jack. You get a display that actually looks pretty readable. They aren't the biggest digits I've ever seen, but here in normal room lighting they certainly seem entirely adequate to me. As you can see, the display is indicating high voltage right now. We've actually moved to the 300 volt DC volts measurement setting. 300 volts is the claimed highest voltage that this multimeter can measure. Whether or not it will operate in excess of its limits, I do not actually know, and I don't have a really good way of testing that, but if I figure something out, we might see if it will actually read in excess of its limits, or if it does the intelligent thing and cuts out the way that it's supposed to. Being as this is a manual ranging multimeter, you have to choose the appropriate range for the voltage, current, resistance, or other signal that you might happen to be measuring. Fortunately, this is nothing like as daunting as it seems, and while I'm not intending this to be a multimeter tutorial, people have asked me to do one in the past. Maybe that's something that will happen in the future. For right now, I'll say that if you have a manual ranging multimeter such as this one, and you're not sure what range to start with, take a look at what you're measuring first. Are you looking to measure current in a circuit, resistance in a circuit, voltage in a circuit? You have to ascertain that first. If you're standing in front of an outlet in your kitchen and you want to know whether or not it's working, then yeah, you're probably measuring volts alternating current. So you want to make sure to set the meter for that. And if you have a manual ranging meter, I keep wanting to say multiple, I don't know why, but if you have a manual ranging multimeter, start at the highest range of measurement. And if you find that the reading you're getting falls well within the capabilities of a lower range of measurement, you can actually switch down to that lower range. Not only will that possibly give you a more accurate reading, it will also frequently give you more digits worth of precision with any multimeter. Not that dead-on precision usually matters for most things that you're going to be doing around the house. As far as volts DC are concerned, there's a maximum of 300 and there's a minimum of 200 millivolts all the way down here at the bottom. So you probably could use this to check things like millivolt ignition systems or thermostat systems. If you have a furnace or a boiler that uses an old style millivolt system or a gas thermocouple of some kind or another, you could verify that it is actually outputting a voltage of some kind. The resistance ranges, ohms resistance, goes as high as 2 mega ohms, which I actually view as a little bit limiting, but again, for anything you're likely to find around the house, it's probably sufficient. And it goes all the way down to 200 ohms. You can actually read fewer ohms resistance than that. That's just the smallest range that this meter offers. However, it will happily display lower resistances than that. You cannot, however, go above its maximum rating on resistance. And again, if you're not sure what kind of resistance you're working with, the same rule applies. Make sure that all voltage is removed from the circuit, otherwise you may very well pop something. And then start at the highest range and work your way down. Going past all the resistance ranges, before I do that though, I will say I'm very pleased to see that this multimeter reads open loop, overload, or open line. In any event, it says OL on the display. And that is a welcome departure from the various DT830 and ICL 7106, 7107 based multimeters that are just out there in droves. Those, when they are indicating an overrange condition, display only a number 1 over here. Not only do I find that irritating for reasons that I can't really explain, I also think it's very confusing to someone who's new with a multimeter and doesn't know why it's displaying a lonely number 1. Has it died? Is that what it's measuring? Is it trying to tell me that it has a problem? It's nice to see that this one actually gives you the OL indication. There's also a diode testing range whose capabilities are at this point unknown, but we will test it a little bit later and see what kind of things it's capable of checking on the diode testing range. This is a test of a diode's forward voltage. Simple silicon diodes like 1N4001s through 1N4007s will typically have a 0.7 or so forward voltage. LEDs are typically higher. White and blue LEDs, you oftentimes see those somewhere around 3.6 volts DC. Speaking of volts DC, there is a rather hokey battery testing function that's included with this meter. It has settings for 9-volt batteries and it has settings for 1.5-volt batteries. I'm not really convinced of the value of this mode of operation. Yeah, you can use it if you want, and it probably will tell you if your battery is hopelessly dead, but it's very likely that you knew it already, especially if you just swapped a new battery into the device in question. And don't most of us have enough batteries around our house that we could simply swap one into another device and see what's going on? I say this isn't very useful because these ranges apply a small load to the battery in order to draw current from it. In the 9-volt measurement mode, it's typically pulling around 4.5 milliamps worth of current. In the 1.5-volt measurement mode, it actually pulls considerably less current out of the battery, usually about 1.5 milliamps worth of current. And neither one of those are an appreciable load to a battery that's even slightly good. So they just don't load it down enough to make a good test. But it's there if you want to use it. Going forward a couple clicks on the control wheel, the mode selection dial, we have the 10 amp direct current testing range. Again, I would urge caution with this. I don't imagine this meter or its test leads are really up to the challenge of making a 10 amp test for any length of time. And if you go too far above that, you will pop the fuse. You'll pop the fuse at 10 amps, but it might take several minutes. And they tell you right here, 10 seconds maximum every 15 minutes. That's because not only the test leads probably need to cool down, but so too does that copper shunt that I showed you earlier in the video. So you can use it if you want. I don't see that there's really any great reason to do so. The smaller current testing ranges might come in handy though. We have a 200 milliamp testing range, we have a 20 milliamp testing range, and then we have a 2000 microamp testing range. It's actually a little bit high for this kind of an application, but if you were going to test something like, say, a flame sensing rod inside a furnace, which produces a small electrical current when it's working properly, the microamp testing range is for you. And then we move to the final two testing ranges on this meter, both of which are for AC voltage. There's a 200 volt setting, and there's a 300 volt setting. And as you can see, when we switch over to the 300 volt setting from the 200, not only do we lose a digit's worth of precision, but the HV indicator also comes on once again in the meter's display. And of course, certainly any voltage that is above about 30 volts AC or so should be treated with the utmost in respect. So now I've given you a pretty good tour of everything that this meter does, what it looks like inside. Let's go ahead and find out just how accurate it is and whether or not it actually works properly. So here's our first major test. This is AC line voltage. These meters have simply been plugged into an outlet in the kitchen. Very simple and easy test to make. And if we go ahead and take a closer look at the Hyper-Tough meter, you can see that it's reading 126 volts AC even. My line voltage is a little bit high around here. By comparison, the Southwire meter, which I believe to read a bit low, is reading just a half volt lower than the Hyper-Tough. However, there is a very important qualification that has to be considered when you're making AC voltage measurements with a simple, inexpensive meter like the Hyper-Tough model. The overwhelming majority of inexpensive multimeters are designed only to measure an alternating current waveform that has a nice, smooth sine wave shape to it, as would be provided by your electrical utility company, or as should be provided by your electrical utility company. This is what they call an average responding meter, in that it's been calibrated to provide a correct value for an alternating current waveform that's a nice smooth sine wave. By comparison, more expensive or better meters are typically designated as being of the true RMS type. They actually perform the necessary calculations to get a correct value even for distorted and misshapen or noisy alternating current power waveforms. And that's what this test is going to demonstrate. I have an inexpensive AN8001 multimeter sitting over here. This is a true RMS type. And then I have the Hyper-Tough average responding meter over here. And they're both plugged into this American Power Conversion uninterruptible power supply. When I turn this uninterruptible power supply on, at first it will be on the AC power line, and both meters will read very similarly, and they will both be reading correctly. But then it will go and perform a self-test, and when it performs the self-test, its inverter switches over to power the built-in outlets, and the inverter actually outputs what they call a simulated sine wave, or a stepped approximation to a sine wave, which is actually a square wave signal that has periodic drops to zero level before it transitions and changes polarity. So the first thing we'll see is the line voltage. And again, both meters are within a few counts of one another, but look at what's happened now that the inverter has switched on. The Hyper-Tough meter reads very low, while the Aneng was still reading correctly. If you plan to use this multimeter with alternating current sources that do not have a sinusoidal waveform, it will lie to you, and this will not be the meter that you will want to use for that task. I am pleased to report that a problem very commonly seen in the inexpensive DT830 multimeter series is not present in the Hyper-Tough, and that is the indication of spurious voltages that do not actually exist. For example, if you have the range selector incorrectly set and you attempt to measure alternating current on a DC source where there is no alternating current waveform riding along, if you do that on a great many of the DT830 meters, like this Centec that's powered up right now and sitting next to the HyperTough, you will see that it gives a spurious indication of voltage from a 9-volt battery, even though it's been set to measure alternating current voltage. I assure you that battery is most definitely not outputting AC. I'm pleased to see that the HyperTough meter, conversely, is not impacted by this problem. Sometimes with a large enough direct current source it will produce a momentary reading, but it always corrects itself right away. And again, it's not all of the DT830 multimeters that have this problem. This one definitely does not, but it is definitely a notable exception and also a good bit better built than most of them are. Conversely, if you have the HyperTough meter connected to a source of AC voltage, yet it is set to measure direct current voltage, you will not get an errant reading there either. However, I cannot speak to whether or not the HyperTough meter will be confused and behave incorrectly in the face of wiring that is carrying both alternating and direct current signals at the same time. I suspect it could possibly have an issue with that, but I do not have any way to test it. Here's a set of generic banana plug style test leads that have been connected to the HyperTough meter, and I am pleased to report that they actually plugged in perfectly. There are no exposed contact surfaces or other issues. So despite my initial concerns about this issue, it appears not to be a problem for this meter. Of course, with these leads attached, that means it's time to take a look at the resistance measurement capabilities and accuracy of this particular meter. And here to do this, I actually have a resistor substitution box. When you're doing a review on a multimeter's resistance measurement capability, you really should use resistors of a much tighter tolerance than just 1%. But again, as I've said in previous reviews, this is what I could get. So we'll go ahead and we'll start with the meter set to its highest resistance measurement range of 2 mega ohms, and I am just curious as to whether or not it might have capability that exceeds its indicated and published specifications in this regard. So we'll start by switching in 3 mega ohms worth of resistance. And right away the meter goes to its overload or open line indication. It did so very pleasingly quickly. Of course, I would expect nothing less from a manual ranging multimeter. So we'll go ahead and we'll cancel out that resistance and we'll switch in 2 mega ohms exactly just to see where the line might be. And it reads 1.990. Very, very close. Let's just see if we can switch in maybe 100,000 more ohms. And it goes right over the limit. So apparently it's pretty tightly limited to that 2 mega ohm capability. We'll see if we can actually find the line right here. If I switch in 10K, it will read correctly sometimes and not others. So apparently it is pretty tightly limited to 2 mega ohms worth of resistance. Let's go ahead and step down now to the 200K mark, and we'll switch in 200,000 ohms worth of resistance. And again, it provides a satisfactory and certainly well within tolerance indication. So we'll go ahead and step down to the 20K mark now. And it's a little bit off there, but again, I'd say that's well within tolerance. We'll step down to the 2K, 2,000 ohms resistance range, and we'll put 2,000 ohms worth of resistance on it. And again, it gets very, very close. The readings certainly do appear to be very repeatable across ranges, and then we'll go down to the 200 ohm range, and we'll switch in 200 ohms, see what it gives us. And again, we'll just try to see at the low end of the range how far we can go over that. Okay, 10 ohms was too many. Let's try 1 ohm, 2 ohms. 2 ohms sends it over. So we'll subtract 1. I have 3 ohms worth of resistance over 200. 203 ohms worth of resistance. 199.7, 199.6. I think that's probably as close as we're going to get. So it definitely does not have a lot of over-range capability, nor can it apparently exceed its published specifications to any significant degree. I spent some more time taking resistance tests on this meter and comparing them to see how accurate it was. And what I found is that the accuracy of the meter very probably exceeds that of my test setup. I found that in the worst case it was just shy of 1% out, and in the best case it was just under 1/4% out. And again, both of those numbers exceed the accuracy of my test rig, so I'm prepared to say, within reason, that the HyperTough meter's resistance measurement range certainly appears to be extremely accurate, as well it should be. The diode testing range is rather less exciting. While it's certainly more than adequate for all your garden variety diode testing needs, such as 1N4000 series diodes, it's not up to the challenge of testing LEDs, at least not very many of them. The red LED that's attached to the meter's test leads right now is the only one out of this entire box that it would light and test to a satisfactory degree. It could not even manage to illuminate the green ones, and the yellow ones barely showed up as well. The owner's manual for the HyperTough meter indicates that the testing voltage for diodes is 2.2 volts DC, and that certainly seems close enough to reality. However, if you load it down to any significant degree, the available current for testing a diode is extremely limited, at right around 700 microamps or thereabouts. And that's just not enough to test a lot of LEDs. I don't personally ascribe a great deal of value to the battery testing functionality of this multimeter, but if it means a lot to you, I think it's worth considering that the indicated figures for battery test current draw in the manual seem to be a typographical error or completely made up, maybe even both. Because in testing with known good batteries, I cannot get figures that match what's indicated in the manual. Testing a 1.5 volt battery, which would be something like a triple, double A, a C battery, D battery, basically any kind of regularly used battery that doesn't happen to be a 9 volt, they indicate that the test should consume 20 milliamps worth of electrical current. If you test a 9 volt battery, it's supposed to draw 5 milliamps worth of current. Here I have two brand new 9 volt batteries, or at least near enough to. The one on the right is brand new, the other one is only very gently used. And in testing these, the figures that I get are somewhere in the neighborhood of 9 milliamps worth of current draw. That's the battery on the left. This is the battery on the right. As you can see, it's a little stronger in terms of current delivery. I do think that could be a valid test for a 9 volt battery, but the results are much less encouraging when you test any other kind of battery, such as these two shown right here. In both of these cases, I've noticed that it only seems to pull about 1.5 milliamps worth of current out of the battery, and that's nothing for even a AAA battery to deliver over a very long period of time. So where the 9 volt battery test might be plausibly useful, I think that the 1.5 volt battery test is nothing more than a curiosity. Here is the beginning of the precision voltage reference tests. I have allowed the reference to sit here and stabilize for the past half an hour or so. Right now it is operating on the 2.5 volt setting, and if we head over to look at the meter, it is right on the money. Here things are now at 5 volts DC output from the precision voltage reference, after allowing things to stabilize for another period of time. The precision reference has now been set to output 7.5 volts. And again, the meter is giving a very accurate result, certainly well within its specifications. And finally, here's the 10 volt setting configured on the voltage reference and indicated over on the display of the meter. Again, it is extremely close to perfectly accurate, if not dead on. I'm certainly not going to quibble over a tiny digit's worth of precision. Here's a test setup that I cobbled together out of a variable regulated power supply as well as the precision voltage reference in order to determine not only where the HyperTough multimeter's low battery threshold is, but also whether or not it continues to be functional, and if so, how accurate it is if one should happen to ignore the low battery warning and attempt to use the meter anyway. However, before I get to that, and since the variable regulated power supply is out here to remind me, I do want to talk briefly about tests I made to determine the capabilities of the test leads and the current shunt within the multimeter, as well as their limitations. Now this power supply is limited to 5 amps worth of output current, so that's the highest my test could go using it, and I didn't feel like cobbling something else together involving batteries and resistors and loads and all that kind of stuff, because I really don't have a lot of that stuff around here to actually test with. What I found is that the test leads seem to be perfectly fine, measuring at least 5 amps worth of current. They don't even get slightly warm in the process. However, the current shunt within the HyperTough meter is definitely the limiting factor here, because it got way too hot to comfortably touch it after just a minute or two worth of testing. Now, you certainly should never make a current test that long, especially when the meter tells you that the duty cycle is something like 15 seconds on and 10 minutes off. So here we are with the battery test all set up and ready to go. The precision voltage reference is supplying 10 volts at the moment, and the variable regulated power supply is outputting 9.1 volts into the multimeter, which should simulate pretty faithfully a brand new, fresh, and certainly usable 9-volt battery. So let's go ahead and start winding things back here, and we'll see where the low battery warning kicks in. We're down to 8 volts. I suspect the threshold will be somewhere around 6, as it is with most other inexpensive meters that run from a 9-volt battery. We're now at the 7-volt threshold, and the low battery indicator has illuminated. Let's see if maybe we can narrow it down a little more closely than that as to where it turns on and off. Okay, at 7.3 volts it goes off. And at 7 volts even it comes on. We'll keep going down here, and we'll just see at what point the meter stops functioning or if it becomes inaccurate along the way. We're at 6 volts right now, which is well and truly indicative of a 9-volt battery that's past its prime, and the meter still appears to be indicating accurately. Now, it is worth mentioning that just because the meter is indicating accurately on DC voltage right now does not mean that it would indicate accurately on other testing ranges, especially those like the diode test that require more current to operate correctly. So when your multimeter tells you that a low battery issue exists, you should always replace the battery straight away. And it's nice to see that the HyperTough meter does in fact have a warning to tell you that the battery is low. That's the symbol to the left of the leading digit in the display. I'm sure you knew that already though. Let's keep on going down here. We just crossed over the threshold into 5 volts. Now we're at 4.5. And I've got to admit, I did not expect it to be working at this low of a voltage. We're now down to just under 3.5 volts DC. 3 volts even. The display might have lightened a little bit in color, but even it is still very readable. That's not just an illusion of the camcorder. We're down to 2 volts, 2.1 volts. And as you can see, the display on the meter just started scrolling. That's the refresh frequency, which undoubtedly is no longer sufficient, as the built-in microcontroller and measurement chip is no longer functioning correctly, and now it has finally failed to indicate the correct voltage. Still has 10 volts applied to the input. If I go up to 2.2 volts, it comes back and starts working properly, but it reads just a couple of tenths worth of a volt too high, but the threshold is very close. If I go down to 2 volts even, the display starts flashing, and at just under 2 volts it blanks out completely. So this meter certainly gives you plenty of warning that the battery is used up and must be replaced in order to ensure continued and accurate functionality, and it also appears that it can get everything that a conventional 9-volt battery has to give. Both of these are very good signs, and I'm pleased to see that it behaves in this manner. My rather informal tests show that the HyperTough multimeter consumes about 1 milliamp or less worth of current, depending upon which testing range is selected, and so it ought to have absolutely exceptional battery life. Here I have the HyperTough meter once again connected to the variable regulated power supply, this time to perform a DC voltage accuracy test. I would certainly expect that it will be very accurate in this regard, but since we're reviewing this thing, we might as well check it out. I'll just move myself over here to the other side of the camcorder and the tripod, and we'll start cranking up the voltage a little bit at a time, just to see how well it tracks with the variable regulated power supply's built-in metering, as well as that of the meter that it's sitting right next to. And indeed, everybody here is within a few counts of one another. The least accurate indication by far and away is that of the variable regulated power supply itself. So we'll go up to 1 volt even here. And we'll go up to 2. And because I am on the 2 volt scale on the Hyper Tough meter, I will actually have to go ahead and turn it up a range at this point. By doing so, I lose a digit's worth of precision, but there's still enough there for almost any low voltage application that I can think of, at least that you'd use this kind of a meter for. Those who need something with much more accuracy and precision at the low end of the scale will know it already, and they won't waste their time with a meter like this. Response time seems to be very good. We'll go ahead and make some bigger jumps here. Go up to around 5 volts. Of course, I'm using the coarse adjustment as a fine adjustment because I just used the fine adjustment to bring up the voltage a little bit, and so it tends to move in big leaps and bounds with only tiny little adjustments. There we are, 12 volts even. And we'll just go ahead and crank it up. I'm in the 20 volt scale right now, so I'll soon have to range up in order to keep the Hyper Tough meter reading. So we'll go up to 200 volts DC now. And again, you lose another digit's worth of precision, but I still don't see that as a serious problem for anyone who's likely to buy one of these. But that lets us go all the way up to the variable regulated power supply's maximum. And again, everybody here is within a few counts of one another. So I'd say it passes the DC voltage accuracy test. Let's try it with AC voltage now. Both the Hyper Tough meter on the left and the Aneng AN8008 on the right are now hooked up to the output of my variable auto transformer, which is itself plugged into an AC outlet and presently set somewhere around the 115 volt mark. So let's go ahead and turn it on and just see what happens here. Both meters settle onto a reading pretty quickly. And again, they're within a few counts of one another, certainly more than accurate enough for the kind of things that a person who would buy this multimeter is likely to use it for. So we'll go ahead and turn down the voltage now. That's as low as it'll go. And then we'll just start bringing it up a little bit at a time, just to see how the two meters compare with one another. And now we're all the way up at the variable auto transformer's maximum output of around 154 volts AC. And here again, although there is a bit of a gap between the two meters and it has increased, I would say it's more than intolerance. And here we are at the end of the review for this Hyper Tough digital multimeter from Wal-Mart. If you've made it this far and actually watched the entire video, I want to thank you for your time. I always do appreciate it when people watch the entirety of my videos, and I'm always interested in hearing constructive commentary from you, the viewers. So I look forward to further discourse down in the comments area. Meanwhile, to try and wrap this up, to be perfectly honest with you, I did not think that I would end up liking this digital multimeter as much as I did. If it is all the multimeter you can afford, I think you'll be very happy with its performance. Likewise, if you're just starting out and this is going to be your first multimeter, I think you could do a lot worse than to choose this model, and again, I would highly recommend it. Plus, if you ever do outgrow it at some point down the road, you can always throw it in the cabinet or your car or truck as a spare, or you can even give it to someone you know who might be starting out with electronics and needs their first multimeter. But before that day comes, I really think you will get many years of satisfactory and reliable service from this inexpensive little multimeter, and so it is that I would recommend it. In fact, there are really only two things about it that kind of rubbed me the wrong way. One of them is a very minor nit, and the other one's an extremely common design shortcoming, so it's hard to come down on the manufacturer too hard for having made that same mistake here. First, it can't test alternating current amperage. If you need to do that, you're going to have to look at another multimeter because this one just can't do it. Not that I'd really recommend it at something in this price bracket. If you need to make those kind of measurements, you're probably better off buying a clamp meter or certainly something a little higher end than this. The other criticism that I will level against this meter has to do with its lack of a stand. This can make it rather inconvenient whenever you want to set it up somewhere and take a measurement with it placed at an angle, instead of being able to simply flip out a stand from the back and have it sit there nicely and steadily until you're done with it. You have to arrange some sort of awkward contraption involving other boxes or random objects that you find, and the whole while you have to hope that the meter is going to remain stable. But other than those two minor things, I certainly do like it a lot. Again, I'd like to thank you for watching this video. I highly recommend this multimeter, and as always, I am interested in hearing your constructive commentary. And so here it is that we are now at the end of this video review about the HyperTough digital multimeter from Wal-Mart, which just fell over dead. That's never good for a review.